alkyl halide to alcohol, we can go for substitution. Sodium hydroxide in aqueous medium. Or else you can convert to cyanide, cyanide to carboxylic acid, carboxylic acid to alcohol. Okay. Now we'll just make this a very specific. Alright, look at this. Look at this. I have CH3, CH2, Cl. How can I form it from CH3, CH3? How to get chloroethane? You're going to remove an hydrogen, introduce a fluorine. How do you do that? Add a chlorine in the presence of free radical mechanism, right? So that means from R you can get RCl by free radical mechanism. Understood? Yes. So these are the ways you can prepare alcohol. But for a studying purpose, you have a specific reaction. Okay. But this is useful for conversion. If for your exam you are asked, how will you convert ethane to ethanol? How will you convert?
CH3, CH1.
Ethane you convert to chloroethane, chloroethane to ethanol. Are you understanding? If you understand this properly, if you learn this properly, conversion is easy. No other work to do. This is the route map that you have. But you need to know how to spot the route map. Understood? Got a point? Have you written this route map in your notes? Write this map. Write it down. See, this is for aliphatic. Whenever aliphatic conversions are given, you can follow this. Okay? We'll go for the next one. First one is hydrocarbon. And the hydrocarbon you have two methods. We completed. Next one is from alkenes. So from alkenes, we have the first kind. Simple one. CH2 double bond CH2 if you take. Do acid hydrolysis. You do acid hydrolysis. One side you add H plus. The other side you add OH minus. Right? What rule are you following?
Anti-mark.
You follow Markovnikov's rule. What does the rule say? Negative part of the addendum is added to carbon having less number of hydrogen atom. Okay. So based on this is the attachment we are doing. But then we'll have to write the mechanism for it. Right? So see, this is symmetric. Symmetric means you can add OH over there or this carbon, it will not matter. But when it is asymmetric, when there are different number of carbon, like 3, 4, 5, 3, 5, 7, 9, the odd number of carbon atom, we have to follow Markovnikov's rule. Or is it symmetry? No. Both the sides it's same. For example, say I am taking CH3, CH, double bond CH, CH3, and to this I am adding water. Will it make a change here? Any change you will see? You add OH over here or over this carbon, it means the same, right? Because both the carbon has same number of hydrogen atoms. So even number when you are having, when you have symmetry, Markovnikov's rule is not necessary. But when you have an odd number, if for example I have something like this, Then now is this important? It is important, right? So just know this. Markovnikov when there are odd number of carbon. So what is the first step in the mechanism? First step of mechanism, water reacts with H plus in order to form H3O plus, right? Water, oxygen has lone pair of electrons. Don't write. Look at the board. Don't write. Stop writing. Already you have studied this. Have you not studied? Then why are you writing? Look at the board. Water, oxygen has lone pair of electrons. That lone pair should attack H plus. Multiple times I have told you, only the rich should be attacking. If you don't have electron, can you go and attack? No, you should be having electron. Only then you can purchase something. You have money, you can purchase. You have no money, you cannot purchase, right? Same concept. You have electron, you can attack. No electron, no attacking. Okay? So H2 plus H plus, H3O plus. Second step, what you're going to do? You take your molecule, whatever molecule, symmetry, whatever is given. Okay, you write the dark plus H3O plus. Now you're not supposed to write this structure. How do you write? How do you write? You write along with the hydrogen, put a positive charge on oxygen, not somewhere here. You'll have to write on the oxygen atom. Okay? Now next step, what do you do? Who attacks who? Double bond is richer, so double bond is attacking oxygen. Don't make an attack like this where the oxygen is somewhere over there and your attack is almost closer and not attacking the oxygen. This is not an attack. There is so much space, right? Attack should be proper, right next to it. Attack. Okay? Next, what will happen? Wait. What am I doing? So here the attack is happening on the hydrogen. Hydrogen is giving the electron to oxygen. So what do we have next? Yeah, you have CH2 with the hydrogen attached to carbon, single bond, CH2. The carbon is carrying positive charge. Next, what do? Water is being separated along with its lone pair of electrons. In the third step, carbon is having positive, so you're going to write CH3, CH2 with the positive sign. Next, what do? Yeah, we'll bring the water back, write the structure of water properly, and who will attack whom? Oxygen's lone pair will attack the carbon. You can make the attack like this, but we'll make a bit presentable attack like this one. Okay, got it? Just to make it look presentable. Then you have CH3, CH2. Should I write like this? Should I write like this?
Plus.
Okay, plus. Should I write like this?
Attack.
You're not supposed to bond like this. This bonding means it is bonded to whom? Hydrogen. Hydrogen cannot be bonded. Who is bonded? Carbon is bonded. So you'll have to write from carbon, oxygen. Oxygen carries positive charge. Now what will happen? Next step, who will come and attack?
Water.
Now water will come and attack the hydrogen. You give back the electron to oxygen and you have CH3, CH2, H with the lone pair of electrons. Got it? So, and plus who is there? H3O plus. So you have invested H3O plus in the first step. So that should come up last. That is a good mechanism because catalyst not undergo chemical change. It should be coming out at the end. Okay, it's not like a byproduct. It is a catalyst that you have used in the initial step. It comes back in the final step. Okay, so this is your mechanism. See the attack, how it is made. Do the attack properly. See, I can also make it like this, but if I'm doing like this, it doesn't have any meaning over there, right? Because it is attacking on the positive side. I want it to attack on the oxygen because I'm giving electron back to oxygen, not to the positive side. So know where you are placing the electron. Do not look at your board. Look, notes. Look at the board. So from the bond to the oxygen, once the oxygen lands, you will have to write the lone pair. If you're not writing lone pair, then what is understood? It still is positive, there is no electron, right? So again, you'll have to do the lone pair and a bend shape, attack properly, give the connections properly. Carbon is positive, on the head of the carbon, positive sign should be there, not at this corner. Okay? Yeah. So that is all for your mechanism of from alkene to alcohol. So this is symmetric. When you are doing asymmetric, say we have CH3, CH2, CH. Okay. Now consider this one. Which carbon will get the OH?
Second carbon. CH.
The second carbon will get the OH, right? In the first step, you need to make sure that you are writing the product. Always when the conversion is asked or when the mechanism is asked, first step, make sure you are writing the product. Only if you write this product, when you are making the attack, you will know which carbon should get positive charge. Now in this, the central carbon, this carbon should get positive charge. So you will move based on this. Right? Now if you're not writing the product, then what happens? This carbon can also get positive charge. Right? Are you understand me? So always write the product first and then go for the mechanisms. Clear?
Yes, ma'am.
Understood? Will you write the mechanism for this? Right. Write on the mechanism.